Settings are wrong. Okay, now it's audible. Everything is fine. Is it audible, guys? Just a second. Let's look at the OBS. Is yes, the pulse is coming here. You're not able to hear me. It's audible. Okay. Strange, right? Sometimes machines do not work. Obviously, they have some probability factor. Okay. So chalo, what I told is basically, so we have started this differential equations. So in the last class, we focused on formation of differential equations. Okay. So we focused on the formation of differential equations, and of course we have seen what is the necessity to learn these differential equations. So many times when you try to model physical systems, these physical systems will end up with the differential equations. So there's a strong necessity to talk about the solving techniques of differential equations. Okay. In the last lecture, we have started this topic, and before we start, I advise you to join this Telegram channel so that any content on this YouTube channel will roll out first on this Telegram channel, so that you'll be kept in regular contact with the ongoing things. Okay, so that you won't miss and you'll have continuity in learning the things. And of course, this is our personal Telegram channel, so you can join if you feel like, if you want to get in contact with me, and if you feel that me or my student community can help you out, you can just scan this code and join the Telegram channel actually. Okay, and let's see. I also advise you to install this Unity so that you can have all your doubt points, holes at a single particular location, so that the complete track of your ID will be at one particular place. Okay, so that whenever you log in and just check it up, you can find all the things at a particular place actually. Okay, so let's see what we have learned in the last lecture. The last lecture we have seen order, degree of a differential equation, and of course the definitions remain same. Either you take a ordinary differential equation or a partial differential equation. So we have seen normally in case of ordinary differential equation we involve only one independent variable, but in case of PDEs or partial differential equations we involve at least a couple of independent variables actually. Okay, so we have seen examples and all, and we have also put enough focus on forming of a differential equation. Okay, so forming of a differential equation. So we have seen that formation of differential equation. So we have seen the classical technique, like if there are n number of arbitrary constants in the simplified form of the solution, then we differentiate the function n times, and using this first n derivatives we'll try to eliminate the arbitrary constants in the solution. Okay, so that's how we can actually form a differential equation, and we have seen a lot of good examples actually in the last lecture. So in today's class we basically focus on the first order differential equation. Okay, so we'll see the solving techniques of the first order differential equation, and in solving techniques of first order differential equation we have different forms. Of course, at least within the GATE syllabus limits, we have the variable separable form, first order homogeneous equations, and first order non-homogeneous equations as well. Okay, so in today's class we'll start our discussion by looking at the first order equations, and then eventually we'll move slowly, okay, to the first order differential equations, and slowly the types of the differential equations like variable separable or homogeneous DEs, non-homogeneous DEs. We'll look into all these things. So let's start with first order differential equation. So the name itself tells you the order of the differential equation is 1 actually. So one basic classification again in ordinary differential equation, a broad classification is first order equations and also higher order equations. Higher order equation is any equation of order 2 or beyond that, 3, 4, 5. We'll encounter those situations as well as we move forward, but first order differential equation actually. Okay, so let's see the general form. The general form of a first order differential equation, a first order differential equation is dy by dx is equal to some function of f of x comma y. Okay, so normally it can be a two variable function f of x comma y. So this is the general form, or sometimes we can also write this as, if this is expressed as, if f of x comma y is equal to minus m of x comma y comma n of x comma y. Again, these are continuous and differentiable functions, of course. So like if you have a function x square y, you can write it as x square y by 1 actually. Okay, so this is a constant function, or you can have something like x cube by e power x. You know, this is x cube y by e power x. You can have things like this. So in general it can be a two variable function, and any two variable function can be expressed as a ratio of two functions again. So if you express it as a ratio of two functions, this implies dy by dx is equal to minus m of x comma y divided by n of x comma y. And if you simplify this, we get m of x comma y dx plus n of x comma y dy is equal to 0 actually here, where this m comma n are functions of x comma y. So the general form of a first order differential equation, either we define it in this particular format or in this particular form, both are actually the same thing. Clear to all of you? Yes? Did you all understand how we actually define the first order differential equation? And if you quickly work out certain examples. 1, dy by dx whole square is equal to 2xy, let's say this. Okay, so if you have this equation, then clearly the order of this equation is only 1, okay, because it's a first order equation clearly. And second, maybe you can write one more example, since as I told you, this complete module will focus only on the ordinary differential equations. Then we'll start the partial differential equations, but in between we'll teach Fourier series. Okay, so let's focus for the time being on the ODEs, ordinary differential equations. So dy by dx is equal to maybe something like root of 1 minus x square minus y square plus x square y square, something like this. Okay, so these are certain equations obviously. Okay, or maybe third, you can see dy by dx is equal to x square plus y square by xy plus maybe say some y by x, will complicate the story, so plus y by x. So all these equations are first order equations because the derivative which is involved is only of first order. Clear? So these are the first order examples actually here. Like in this case, if you take LCM, this dy by dx is equal to like a ratio of two functions. Okay, or in this case dy by dx is equal to some function of x comma y. So these are the basic first order differential equations. Now how to solve these equations, that's the story. Okay, so let's see. So this is the first order equations, and many times you end up with first order equations. Like in yesterday's case, if the force is a constant, f equal to m into dv by dt, so or d square x by dt. Okay, if you write in terms of velocity, for example. Okay, so some force which is a function of velocity is equal to mass into dv by dt, let's say, then this is again a first order differential equation because mass is a constant. Dv by dt is equal to some function of v comma t actually. Okay, so like this we keep getting a lot of first order equations. Now let us solve those equations actually. So the first technique which we use to solve those equations is the variable separable form. Clear? So let's see the first case, variable separable form. If the first order equation is dy by dx is equal to f of x comma y actually here. Okay, so this is f of x comma y such that this is the symbol for such that f of x comma y can be split up into two functions, can be split up into product of two functions actually, such that one function is only in terms of x and another function is only in terms of y. And we have seen these kind of examples when we are doing multiple integrals. When the integrand is of two variables, sometimes it's possible for us to split this integrand into those two functions, and if the limits are constants, we have broken the integral into or basically we have broke the integral into two parts actually. Okay, so similarly, if this function exists something like that, then this implies dy by dx is equal to some function phi of x into some function psi of y actually here. So if you bring this psi of y to the left hand side, 1 by psi of y dy is equal to phi of x times dx, and you can integrate this obviously. Now you know the techniques to integrate this because this is a single variable integration, and this is also a single variable integration obviously. So you know, in single variable calculus we have learned a lot of techniques to calculate the integrations and you can solve. So this finally on solving gives you the sum solution. On solving it, the solution is it gives y is equal to some function of x actually here. That's it. Okay, so since in single variable calculus we have learned a lot of techniques to solve single variable integrations, we can easily solve this. Now let's quickly look at certain examples maybe which can help you up. Examples. First one, y cube dy by dx plus x cube is equal to 0 actually. Okay, so let's calculate this. So it's very simple. If you want to calculate this, then y cube times dy is equal to minus x cube times dx. So basically when you can split a differential equation into two parts such that one side of the equation consists of only a particular variable and the other side of the equation consists of the second variable actually. Like here in this case you can see left hand side is completely a function of y and right hand side is completely a function of x, and if you can integrate these guys, the answer is pretty simple. If you integrate this, y power 4 by 4 is equal to minus x power 4 by 4 plus, as I told you, when you integrate you'll always have a constant plus c, and so you can write this as x power 4 plus y power 4 is equal to constant, some other constant c, okay, because you know if c is arbitrary constant then 4 times of c is also again one arbitrary constant. So this is the solution here in this case, okay. So this is the solution. Now we have something called general solution. General solution. So what is this general solution of a differential equation? The solution which involves arbitrary constants. Like for example, in this place of c, whatever I take, like let's say c equal to 2, 3, 4, doesn't matter, this solution will always satisfy this equation, okay. But in some cases when we normally deal physical systems, we always have something called boundary conditions or something called initial conditions actually, okay. So which tells you, like let's say solve this equation such that y of 0 is equal to 1. Let's say if I take this, okay. So if I give you some initial condition, y of 0 is equal to 1. So let's say from when you are analyzing some physical system, you got the boundary condition something like this. This tells you at x is equal to 0, y is equal to 1 actually here, okay. So this tells you y of 0 equal to 1 means the solution at x equal to 0 is equal to 1 actually, okay. So when at x equal to 0, when the displacement is 0, some parameter y is actually 1. So in such case, this solution has to satisfy this equation. At the same time, this solution should also satisfy this condition actually. So if you substitute, this implies at x equal to 0, y equal to 1. So let us substitute these two simultaneously in this equation. You have 0 power 4 plus 1 power 4 is equal to constant. So c is equal to 1 actually. So therefore solution is x power 4 plus y power 4 is equal to 1. That's all. So now you have this solution. Means basically using some boundary condition we have figured out what's the value of this arbitrary constant. Good evening Ashwini. So see here x power 4 plus y power 4 is equal to 1, and this solution in this case is called particular solution. And why it's called particular solution? The reason being, since this solution has a particular value of c, okay, and c is actually equal to 1. Got it? So do we need to study 11th and 12th maths for GATE exam? To be frank, no, but if your basics are quite less is what you feel, then to initially grasp the things, it's better to learn, okay. Anyway, so this is called particular solution because when this value of c is a particular value 1 which satisfies this equation and this boundary condition, so that's why it's called the particular solution. The difference is, in case of general solution you have some arbitrary constants, but when you substitute the boundary conditions or the initial conditions depending on the problem and get the value of the arbitrary constants, such solution in which there is no arbitrary constant is called a particular solution. Clear to all of you? Yes? Alvin, Molindu, Shravan, Manoj, Krishnaveni, I could read Saurabh, I could read all of these names. So please type in the chat box. Is this clear to all of you? Okay. Okay, fine. So we have solved the equation. Then to get the value of the constant, we have substituted the condition which is given. So basically there is one arbitrary constant. So you need one condition. So to get this, okay. If I ask you, what is the value of y equal to 2 actually, okay. So y of 2, let's say y of 2. If I ask you, this tells you that is at x is equal to 2, what is the value of y? So just put x equal to 2 in this equation. This tells you 2 power 4 plus y power 4 is equal to 1. So this tells you y power 4 is equal to also this is like, okay, fine, let's say at x equal to 0 we have taken, of course. So let's say at x equal to 1 by 2 for example, okay. So at x equal to 1 by 2, because I want to stay in the real calculus. So at x is equal to 1 by 2, y, what is the value of y? So if you replace 1 by 2 whole power 4, this tells you y power 4 is equal to 1 minus 1 by 16. So y is equal to 15 by 16 whole power 1 by 4 actually. and this value you can calculate using a calculator. 15 by 16 whole power 1 by 4, so which is power 0.25. okay, so if you do this 0.9839, so 0.984 is what you can write, 0.984. so let's say if I know the system for which I know the governing differential equation and also some boundary condition to get the value of the constant, then at any given other value of x, okay, so we can have the value 0.984 actually here. okay, so let's see, I'll give you one more question, so try to solve that. dy by dx plus root of 1 minus y square by root of 1 minus x square is equal to 0. So solve this equation, so solve this such that y of 0 or y of 1, let's say, is equal to, so y of 1 is equal to, maybe you can take something like y of 1 is equal to, so let's say 0. okay, so y of 1 is equal to 0. Then y of 1 by 2 is dash, maybe. okay, so something like this. Yeah, y of 1 by 2 is equal to 0. So round off to 2 decimal places you round off. okay, so round off to 2 decimal places. Round off to 2 decimal places. Come on, solve this question. I have given you some time. Think about it. Integer type, then maybe 120 seconds. Good enough. Solve this question quickly. First order means only order restricted. Decay may be anything. Yes, of course. It can be linear, non-linear, whatever you want. Saga Solanki, arc sin x plus arc sin y equal to constant. But I am asking you the exact value of y of 1 by 2. okay, so when you put x equal to 1 by 2, what's going to be the value? That's the question. Come on, do it quick. I have given one condition, initial condition, y of 1 equal to 0. Solve this quickly. Thanks for all the love and celebrations. Come on, a bit faster. 0.98 is the value. Maybe possible. Okay, that's for the previous question, right? Okay. Yeah, so meanwhile others keep entering the answer. I'll start solving. Look, if you look for the solution of this, we have dy by dx plus root of 1 minus y square by root of 1 minus x square is equal to 0. okay, so this can be written as, if you take LCM, or basically if you take it to the other side, dy by dx is equal to minus root of 1 minus y square by root of 1 minus x square actually here. So if you take this numerator to the left hand side and this dx to the right hand side, we have 1 by root of 1 minus y square dy is equal to minus 1 by root of 1 minus x square dx actually here. okay, so that's what you get. So clearly it's in variable separable form. So if you integrate this, then clearly the left hand side is sine inverse y, of course. okay, so this is sine inverse y, and what about the right hand side? This is minus sine inverse x. So you replace some constant, arbitrary constant here. So this tells you sine inverse of y plus sine inverse of x is equal to constant. So this is the solution, but this is actually a general solution. okay, and we want the value of y particularly at x equal to 1 by 2. okay, so let's try to do that. So let's substitute the boundary condition. So what is the boundary condition you have? We have y of 1 is equal to 0, and this tells you at x is equal to 1, y is equal to 0. Okay, so if you substitute both of them simultaneously in this equation, we get sine inverse of 0 plus sine inverse of 1 is equal to constant. So clearly this tells you sine inverse of 0 0 and sine inverse of 1, of course within the principal interval, if you take this is pi by 2, so c is actually equal to pi by 2, of course. Okay, so the constant is equal to pi by 2. So let's see, therefore the solution is, the particular solution is, let's write a word here, this is general solution. So if this is general solution, then if you calculate the particular solution is sine inverse x plus sine inverse y is equal to pi by 2 actually here. Okay, so this is sine inverse x plus sine inverse y is equal to pi by 2. Now you want the value of y at x equal to 1 by 2. Okay, so therefore at x is equal to 1 by 2, this implies, so sine inverse 1 by 2 plus sine inverse y is equal to pi by 2. So what is sine inverse of 1 by 2? You know, sine 1 inverse of 1 by 2 is actually 30 degrees, which is pi by 6. So sine inverse of y is equal to pi by 2 minus pi by 6, which is pi by 3 actually, correct, because 90 minus 30 is 60, you know this. So what about y? Y is equal to sine pi by 3. So what about sine pi by 3, which is root 3 by 2, so which is 1.732 by 2, 1 point, or basically, you know, square root of 3 by 2, 0.866, 0.866, but I have asked you to round off to a couple of decimals, 2 decimals, so this value is around 0.87. Okay, so this is 0.87 is what you get. 0.87 is the actual answer in this case. Okay, it's exactly root 3 by 2. Fine. So you can see every process it's fine. So sine y equal to sine pi by 3 whatever is 0.87. Fine. Okay. So is this clear to all of you? Yeah, 0.866 is the answer, and since I have asked you to round off to 2 decimals, so 0.87 is the actual answer. So let's enter 0.87 if some of you have entered 0.87. So let's see. Decimals, rounding off. Rounding off is the issue. Okay, fine. No. So this question I hope it's clear. Okay, so let's solve one more question since there is some time. Maybe we'll pick one more question actually. If dy by dx is equal to root of, let's take that example which I have given you, plus x square y square. So let's take this. This is a differential equation, and y of y of 0, yeah, 0 is equal to y of 0 is equal to so let's take 1. Okay, so y of 0 equal to 1, then y of any value, general value you can take, so y of 1 is dash. So what is the value of y of 1? Come on, do this question again, round off to 1 decimal place maybe. This time enter the decimals correctly. Okay, so round off to 1 decimal. Come on, do this question. I'll again set the poll. This time enter the decimals correctly. Okay, so integer type 120, yeah. Okay, take 150, no issue. All you have to think a bit. Poll is not working. No, it's working, right? The poll is active. It's okay, just try to solve this question and try to enter the answer. I've given you 150 seconds, 30 seconds bonus to think a bit on this question. Come on guys, quick, already 30 minutes passed. I think in this question variable separable not possible. That's what you think, but that's not the fact. Okay, but it's okay. I have confidently given this example as no. Confidently given this example like in the under variable separable form, so you can do it. It's possible. Yeah. Come on, the time is rolling up. It's not possible or possible? Okay, the poll got ended. Before we solve this question, how many of you honestly feel that it's not possible to separate this into variable separable? And how many of you, or basically how many of you feel that it's not possible? You might have tried, but you did not figure out how. How many of you did not figure out how to separate this into variables? Any idea? This is homogeneous. No, it's not homogeneous because these two terms are of not same degree. This is a constant, which means it's a term of 0th degree. It's a second degree term. This is a 4th degree term, so it's not homogeneous. Clearly, 0.7 is what you're getting. Okay, how many of you feel that this cannot be separated to variables? You have tried, but how many of you could not think of the variable separation? मेरे से भी separate नहीं हुआ, ठीक है, no issue, we'll solve this. Squaring on both sides, maybe that can also hold good, but in order to do the question in terms of variable separable, it's always suggested to have dy alone, okay, not square or cube of that. So let's see a small simple technique. I have given you some small catch here. Look, given dy by dx is equal to root of 1 minus x square minus y square plus x square y square actually. Okay, so this is what you get. Now 1 minus x square into 1 minus y square. Yes, fantastic, of course. Okay, sorry, root are actually problem, then separate. Yes, of course, very good. Yeah, minus x square you can take common, but whatever, you can check it up. This can be written as 1 minus x square times 1 minus y square. That's all. Okay, so if you multiply those two, you'll get this, correct? 1 minus x square minus y square plus x square y square. That's it. So the equation itself is dy by dx is equal to square root of 1 minus x square into square root of 1 minus y square. That's what you have. Now you can separate this guy. 1 by root of 1 minus y square dy is equal to root of 1 minus x square dx. That's variable separable, of course. Okay, now the job next is very simple to you. Sine inverse y is equal to, so this is sine inverse y, of course. So integral root of 1 minus x square dx actually. So what is the integration of root of 1 minus x square? We have seen integral root of a square minus x square dx. I have told you this is very frequent and we keep using it again and again. Okay, so you're watching you from Ghana. Nice, thank you. X by 2 is into root of a square minus x square plus a square by 2 times sine inverse of x by a plus constant, of course. Okay, so you guys got a arbitrary constant plus c actually here in this case. Okay, so this is the integral which I have shown you, I have proven you many times in single variable calculus, of course, even. So let's use this. So a value is 1, so this integration is going to be x by 2 times root of 1 minus x square. Okay, so root of 1 minus x square plus a square by 2, so which is 1 by 2 times of sine inverse x by a, so sine inverse x plus constant. So this is the solution that you have finally. Okay, so sine inverse y is equal to sine inverse y is equal to x by 2 times root of 1 minus x square plus 1 by 2 sine inverse x plus constant. The reason being this integral is root of 1 minus x square, which is same as this. Yeah, correct. So can you all get this? So this is the general solution of this equation. So this is the general solution of this equation. General solution of this equation actually. Yes, thank you. Just follow. Okay, sorry I couldn't read your name exactly. Smart Modium Diang. So let's see, this is the general solution. Okay, so once you have this general solution and we have one arbitrary constant, of course, so I have given up with a boundary condition so that you can just substitute and get the value, of course. Okay, I'm erasing this. I think you might have written the formula, or else you can pause the video and write. So let's see, we have y of 0 is equal to 1 actually. Okay, so if y of 0 is equal to 1, this tells you if you put x equal to 1 and y equal to 0 simultaneously in this equation, we get, sorry, x equal to 0 and y equal to 1 actually. So sine inverse of 1 is equal to x by 2, but x is 0, so 0 into something, it is 0, plus sine inverse of 0, this is also 0, so this is constant. And what is sine inverse of 1 actually here? Sine inverse of 1 is pi by 2, right? Because sine pi by 2 is 1, so sine inverse of 1 is pi by 2 again. So this constant value is pi by 2. That's all. So C is equal to pi by 2. Okay. Now if you replace this guy C as pi by 2 here, the complete solution or the particular solution is, you can see, sine inverse of y is equal to x by 2 times root of 1 minus x square plus a square by 2, so 1 by 2 times sine inverse x plus this constant value is pi by 2. Now you want the value at x is equal to 1, correct? So we are asking what's the value of y of 1. So when you substitute x equal to 1, what's going to be the value of y actually? Okay, so if you put x is equal to 1 in this, at x is equal to 1, so when you put x is equal to 1, this value becomes sine inverse of y, because you don't have any x to put. When you put x equal to 1, this term will be 0, correct? Because 1 minus of x square is 0 actually. So 0 plus half into sine inverse of 1. So again, this is going to be pi by 2 plus pi by 2, of course. Okay, so 0 plus pi by 1 by 2 into x equal to 1. If you keep here, sine inverse of 1 is going to be pi by 2 plus this is one more pi by 2. So pi by 4 plus pi by 2 is going to be 3 pi by 4. So y is equal to sine 3 pi by 4. And what is the value of sine 3 pi by 4? 1 by root 2, because it's same as pi by 4 actually. So what's the value of 1 by root 2? 0.707, right? So this is 0.0707 actually here. So 0.707 is what we have the value actually, right? Yeah. 0? No, right? There is a value here. So you can see when you substitute x is equal to 1, this guy will be 0, because 1 minus 1 is 0, of course. So 0 into 1 is again 0. So this term will go to 0. Plus when you put x is equal to 1, of course, sine inverse of 1 is pi by 2. So 1 by 2 times of pi by 2 gives you pi by 4, plus there's a pi by 2 here. So pi by 4 plus pi by 2 going to be 3 pi by 4 actually. And y is sine 3 pi by 4, which is 1 by root 2, which is 0.707. Okay. Yeah. Clear to all of you? So this is going to be 0.707. And since I have asked you to round off to one decimal place, this guy is going to be 0.07. Yeah, maybe I can put a fill in the blank here. 0.7 is the value. Okay, it's a one decimal place. If I have asked you to round off to a couple of decimals, you would have written 0.71. That's it. Okay, so 0.7 is the actual answer. 0.7. I hope at least this time some answers are recorded. Yeah, poll is not working. Seriously. Okay, strange. Let's look at the leaderboard. Ashwini's answer, only Ashwini Kumar Baiswal's answers are getting recorded. How come it's possible? Yeah, he has done this question in 94 seconds, whatever. But it's okay. I think there is some issue hidden here in the polls. We'll try to figure it out. Okay. So let's see. Let's move on to the next method. Basically, homogeneous equations. Okay. So what are these homogeneous equations? Let's work it up. If the equation, or basically we have seen the general form or the first order DE, differential equation, or the first order ordinary differential equation, you can pick, okay, O, dy by dx is equal to minus m of x comma y divided by n of x comma y. So this is the general form of a first order homogeneous equation. So how to think in the start? In this case, actually I have given you one more advantage. I have taught that example under the heading variable separable form. Okay, so x square y square combination is there, so you have to think something such that it gets into a variable separable form actually. Okay, so that thinking is what you have to cultivate in you, and it comes up with practice. Okay, don't worry. If you cannot think at this point of time, don't worry. When you keep practicing a bit of questions, you next time you know the thought comes in your mind. Okay, fine. So let's solve this. The first order ODE dy by dx is equal to so and so is said to be a homogeneous DE, a homogeneous ODE if m of x comma y and n of x comma y are homogeneous functions, of same degree actually here. Okay, so if these are homogeneous functions of same degree, look, I have given you the definition of homogeneous functions in multivariable calculus, right? So if you remember, during Euler's theorem, I have given you a function. I'm just recollecting this. So a function f of x comma y is said to be a homogeneous function of degree n, is said to be a homogeneous function of degree n if there exists a scalar k such that f of kx comma ky is equal to k power n times of f of x comma y actually here. Okay, so we have seen this condition, of course, but in gate examination he didn't say it's a variable separable method problem. I'll tell you now. Whenever they give you first order equations, just try to separate it into variable separables. Okay, if it do not work out, then you can go for basically you can, if the variable separable method didn't work out, okay, check for homogeneity. If not, check whether the equation is linear. We'll see, okay, in the next 1-2 classes. Okay, so tomorrow we'll teach exact equations and of course integrating factors, and we'll also see the applications of linear equations actually. So in all these cases, when you go step by step, definitely there comes a situation where you can solve the equation. Okay, so we'll see how that can be done in the upcoming classes as well. So let's see this. Telegram channel link, it's given in the beginning of this video, Bharat. Okay, so you can. So let's see, this is a homogeneous function. Like example, we have seen f of x comma y is equal to, say for example, x cube plus 3x square y plus 3xy square plus y cube. Okay, so you have something like this. So clearly you can check each and every term of this equation of this expression is of third degree. Okay, is of third degree. So we'll say this is homogeneous of third degree. Okay, so this function is a homogeneous function of third degree actually, because if you replace this x and y with kx and ky, you can take a k cube common from all these terms and you can write it as f of kx comma ky is equal to k cube times of f of x comma y. So this is a homogeneous function. Okay, so once you decide this m and n are homogeneous functions of same degree, then this differential equation of first order is said to be a homogeneous equation. Okay, and the definition of homogeneity of a DE changes from first order to higher order. Okay, so when the equation is of higher order, let's say second degree equation, second order equation or third order equation, when you have higher order equations, then the definition of homogeneity is something different actually. Okay, but in this particular case, when you have the first order equation, the definition of homogeneity is defined in this particular form. Okay, so these two functions should be a homogeneous functions of same degree. So let's see how to solve these techniques. If f dy by dx is equal to f of x comma y, some function, and this you can write it as m of x comma y by n of x comma y is a homogeneous DE of first order, is a homogeneous ODE of ordinary differential equation. ODE stands for ordinary differential equation of first order. Okay, so let's say if dy by dx is equal to this, the class daily hoga kya? Of course, yeah, why not? We have started it around a couple of weeks back and we are going on. It's okay, no issue. We have almost started the new chapter yesterday, so just follow on. Okay, no issues. And so is a homogeneous ODE of first order, then by substituting then by substituting y by x is equal to some variable. Okay, so maybe v I'll use, okay, because my name is Vinay, so I'll use v. So this implies y is equal to vx. If you substitute this, by substituting y equal to vx, the given ODE converts to variable separable form, actually here. Okay, so this converts to variable separable form actually. So let's take it up whether this happens or not. Okay, so this is one solving technique to solve a homogeneous first order equation actually. Okay, so let's solve this example. So let's look at one example so that it would be better. Example 1. So let's say I give you something like 2x plus y dx plus x plus 2y dy is equal to 0. So let's say this is one equation, or you can also write this as dy by dx is equal to, so dy by dx is equal to dy by dx is equal to minus 2x plus y by x plus 2y actually. Okay, so let's say this is a differential equation. Now clearly you can observe this dy by dx is equal to minus m of x comma y by n of x comma y. These two are two different functions, but both these functions are homogeneous functions of first degree. Yes or no? Correct? Come on, type it quickly in the chat box. These two functions are actually homogeneous functions of first degree. Correct? Can I tell that? So please respond in the chat box. These two guys are homogeneous functions, but both the functions are of first degree homogeneity. Yes? Come on, quick. Manoj, Alvin, Tini, Bharat, Shravan, Chandan, Prakash, all of you. Yeah? Okay. So then I have told you a technique. Put y by x is equal to v or y equal to vx so that this homogeneous equation get converted to variable separable form. Let us check whether that happens or not. So since it is a homogeneous DE, since it is a homogeneous ODE of first order, of course, substitute y is equal to vx. Okay, so y is equal to vx. V is some variable which is of involving both y and x, of course. So what we do is, once you have y is equal to v by or y equal to vx, this implies if you differentiate with respect to x on both sides, because if you substitute y equal to vx on the on the right hand side, it's fine. Okay, so everything gets converted to x, but this dy by dx still involves y, so we have to convert this dy by dx in terms of dv by dx. Okay, because now we are changing the variables. So if you differentiate with respect to x on both sides, dy by dx is equal to, we have two functions, first function into derivative of the second function plus x into derivative of the first function actually here. Okay, so this is what you get, v into 1 plus x into dv by dx actually. Okay, so this tells you dv dy by dx is equal to v into 1 is v plus x into dv by dx. I am purposefully solving this equation because you will see in tomorrow's class we'll solve the same example in a single line. Okay, there is certain technique which I'll teach you. So but for now I'm just showing the classical procedure, y plus x into dv by dx actually. Now if you substitute this guy and also this guy in this given equation, okay, because we are making some substitution, so we have to change the differential coefficient as well. Let's substitute these two in the given equation. So therefore given equation implies this dy by dx can be replaced with this term, v plus x into dv by dx is equal to minus 2x plus y. So y can be replaced as vx, so 2x plus vx by x plus 2y, x plus 2y, y is again vx actually. So if you cancel x, basically x can be taken common and it can be cancelled. So you have v plus x into, or let's write it to the left a bit, v plus x into dv by dx is equal to minus 2 minus v by 1 plus 2v actually here. Okay, so 1 plus 2v. So what we can do is we can actually delete this v here and put a v here, okay, with a minus sign. So ultimately this tells you x into dv by dx is equal to, this is some function of x. So if you simplify, minus 2 minus v, when you multiply 1 plus 2v, minus v minus 2v square by 1 plus 2v actually. Okay, so this can be written as x into dv by dx is equal to, or if you pull this minus sign to the left hand side, we have 2 plus 2v plus 2v square actually. Okay, so we have 2 plus 2v plus 2v square, or if you by 1 plus 2v actually here. Okay, so this is 1 plus 2v. Maybe we can do one more thing. We can delete this 2 on the right hand side and write a 2 here in this. So this actually tells you something like 1 plus 2v by v square plus v square plus v plus 1 is equal to minus 2 by x dx into dv actually here. Okay, this right hand side dv is here itself. So you can observe something. Let's write it little properly. dv is equal to minus 2 by x dx. So you can understand we have made this substitution and we have similarly calculated what is dy by dx actually. So dy by dx is equal to v plus x into dv by dx. Then in such case, after making the substitution and making a bit of algebra, shaking the terms properly, we got the left hand side to be completely in terms of v and right hand side to be completely in terms of x actually. Okay, and clearly this is in variable separable form. Variable separable form actually here. Okay, so this is variable separable form. Clear to all of you? Yes. So please type it in the chat box. Did you all understand the essence of this point actually, what I have written here? You replace y equal to vx and then substitute dy by dx in the given differential equation. The homogeneous differential equation gets converted to variable separable form actually. Fine? Yes or no? Please type it in the chat box. Did you all understand this point actually? This is a homogeneous equation. We have made this substitution accordingly, and after a bit of algebra we got the equation to be in terms of variable separable. Okay, then let's see if you try to simplify this equation. Okay, but left side functions are complicated. It's okay, maybe it is complicated or easy, doesn't matter. We'll try to solve this because we are experts in single variable integration by now. We have done a lot of single variable calculus. So whatever I mean to say is there is only one variable on each side. Okay, and it is clearly separated. Now if you guys integrate this, let's perform some integration for fun. Okay, so if you integrate this on both sides, then what we do is try to observe one thing. If you calculate the derivative of this denominator, okay, so if you calculate the derivative of this denominator, what is the derivative of this denominator? V square plus v plus 1 with respect to v, of course. What is the integration of, sorry, what is the derivative of v square plus v plus 1 with respect to v? Because of course the integrating variable is v. So if you look at the denominator, what's the derivative of the denominator with respect to v? Come on, quick, a bit faster. 2v plus 1, obviously, right? So the derivative of this with respect to v is 2 times v plus 1, or it can be written as 1 plus 2v, whatever. This is exactly the numerator of this function, correct? So this is something of the form integral f dash of x by f of x dx. And what is this value I have given you? Ln mod f of x plus constant. Plus constant is what the value I have given you. Yes or no? So we have given this equation as integral f dash of x. The derivative of the denominator is given by numerator. Yeah, of course, in this case. Okay, so you can check for this particular integration I have given you in the single variable calculus. Integral f dash of x by f of x dx is ln mod f of x dx. So I have given you this. Yes or no? Please type it in the chat box. Okay, then if this is the solution, you can check it up. So this can be written as ln v square plus v plus 1 is equal to this minus 2 I can take out of the integration. This is integration of 1 by x dx, ln mod x plus constant. Okay, so you put a modular sign here also. So minus 2 ln mod x plus constant actually. If you take this term to the left hand side, we have ln mod v square plus v plus 1. This minus 2, if you come take it to the left hand side, we have plus 2 times of ln mod x is equal to constant actually. Okay, and you can see this 2 in the multiplication of the ln can be taken to the power actually. Okay, we know ln x power n is equal to n log x. So this 2 in the multiplication of ln can be taken to the top of mod x actually. Then so this I hope you know, I am erasing this. Fine. Okay, so let's solve this. It is of the form log of something plus ln of some other thing. So this can be written as complete log. So ln b square plus b plus 1 by multiplication actually ln b square plus v plus 1 multiplied with this x square, because mod x whole square is just x square whatever, is equal to constant. So ultimately, you know, if this complete term ln is a constant, then you can write this as this complete term equal to e power constant, which is again some different constant. So this tells you v square plus v plus 1 on x square is equal to constant actually. Okay, because here log of something is a constant, then ultimately you can write this as this function is equal to e power this constant, and e power of arbitrary constant is again some arbitrary constant. Okay, so this is c, but this is the solution. But in this case there is one catch. In the actual equation there is only involvement of x and y. Okay, in the actual equation there is only involvement of x and y actually. V is something which we have introduced for our comfort. Okay, so this question has nothing to do with this v in actual. Okay, but we have made this assumption y by x is equal to v to make the job easy. Okay, so what we are going to do, we are going to substitute this v back as y by x. So if you substitute this back, so substitute v is equal to y by x, of course. So if you simplify this, we get y square by x square plus y by x plus 1 operating on x square is equal to some constant. So if you take LCM, it gives you y square plus xy plus x square. Okay, by x square and by x square, when you take LCM, this x square and the denominator x square gets cancelled, is equal to constant. So this is the actual solution of the equation. Okay, so this is the solution. This is the solution actually here. Okay, so if you have this differential equation, for this differential equation the actual solution is okay. Now in tomorrow's class I'll tell you a technique. Whenever I give you this equation, just by looking at it within 1-2 lines, you can write the complete solution. We can get the actual this solution in just 1-2 lines. Okay, without doing all this process. But I've thought of showing you some common working methodology for homogeneous equations. Okay, got it? Is this clear to you or not? Please type it in the chat box quickly, a bit faster. Just a second. So please type it in the chat box. Yeah, okay. So let's look at one more question maybe. Solve dy by dx is equal to one of my favorite questions as well all time. Y by x. Okay, so this is the question. So let's say when, okay fine, you just solve the general solution, it's okay for this question. So let's take this question. Okay, so dy by dx is equal to, it's clear? Please can you solve one line? Patience. Okay, so let's solve something called exact equations in tomorrow's class. Then when we solve exact equations, you will see, then I'll give you the methodology. Okay, because you right now, even if I give the solution, it's just like for getting the answer, but you don't know what's happening actually. Okay, so let's see, and you know the answer already. So chalo, then let's solve this question. Dy by dx is equal to x square plus y square by xy plus y by x actually. So ultimately, if you take LCM, this complete numerator will be third degree, denominator will also be third degree. So both are homogeneous functions of third degree. Okay, so it's a homogeneous equation. So first of all, can you all convince yourself that this is homogeneous? Yes or no? Please type it in the chat box. Can you all convince yourself that this is a homogeneous equation? Because if you obviously take LCM, it becomes x cube plus y square x plus xy square. So this complete numerator will be a third degree homogeneous function, and denominator would be x square y. So that's also a homogeneous function of third degree. Okay, so this is a homogeneous ODE, and of course it's of first order. You can see homogeneous ODE of first order actually. Okay, then since it's a homogeneous ODE, let's go for the substitution. So solution, substitute y by x is equal to v, or maybe y equal to vx. So this tells you dy by dx is equal to v into 1 plus x times dv by dx actually. Okay, so this is dv by dx. Okay, so that's what you get. Dy by dx is equal to v of 1 plus x into dv by dx actually. So let's substitute these two in this equation. We end up something like v plus x into dv by dx is equal to, so if you replace y equal to vx in this first term, we have x square times of 1 plus v square by x square into v. Okay, so this is what you get obviously if you put y equal to vx, plus means examiner didn't give directly homogeneous function, possible, right? Plus then what about this guy? Y by x is nothing but v. Okay, so yeah, when you have this v, now why this is my favorite is you can cancel these two on both sides. Okay, so once you cancel the v on both sides, then ultimately it's a simple question. So let's get that. So this tells you right, x into dv by dx is equal to x square times of 1 plus v square by x square times v actually here. So if you simplify this x square and x square, you can cancel, then this is again something of the form v by 1 plus v square dv is equal to 1 by x dx. Okay, so this is what you get, 1 by 1 plus, or v by 1 plus v square dv is equal to 1 by x dx. Okay, now again if you take the differentiation of 1 plus v square, 1 plus v square differentiation is 2v, but there is no 2 on the numerator. Okay, so if there is no 2, what we'll do, we'll put 2. Okay, that's it, but we'll put on both sides. If you put only on one side, it's mistake. So multiply with the 2 here and also multiply with the 2 here, that's it. Okay, so this tells you, so now you integrate this. So if you integrate this, 2v is exactly the denominator, the differentiation of the denominator. So the integration of this is as per the logic I told you, integration of f dash of x by f of x dx form. So ln 1 plus v square is equal to 2 into integration of 1 by x ln mod x plus constant, actually some arbitrary constant. Okay, so then again you can do something like this, and if you put it back to the left hand side, so we get something like, if you take it to the left hand side, we have ln 1 plus v square by x square is equal to constant. Okay, so that's what you get, right? Because if you take this to the left hand side, log a minus log b form, so log a by b is what you can write. So if this is a constant, this ultimately tells you 1 plus v square by x square is also some arbitrary constant c. Okay, maybe this is some constant, this is some other constant, so we can retain c as usual. So if you replace, put v equal to y by x in above solution, because the final answer should be in terms of x and y, of course. Okay, so in above solution, so this tells you, in above solution, this guy tells you 1 plus y square by x square is equal to constant. So this tells you x square plus y square is equal to x power 4. Yeah, that's it. Okay, okay, so this is x power 4 is what you get. So this is the general solution. General solution actually. Okay, so is this fine to all of you? Please type it in the chat box. Is that clear to each and everyone? Okay, yes or no, please type it in the chat box. Fine. So that's why it's a relatively easy question, because this integration is slightly simple as compared to the previous case. That's all. Is NID tag matters? I've answered this question right some time back. Okay, it matters like for the first impression. Not only NID tag, even if you have IIT, IISc, MIT tag also, they actually give you the preference for the first time. Okay, once you have the platform, then you have to keep proving yourself. That's it. Okay. If I have, let's say, IIT Madras tag, and if I don't do anything, let's say for example I don't know, I'm good for nothing, then obviously my tag won't, you know, make me to sustain for a long time. Maybe it gives an initial touch, but it won't allow me to sustain for a long time. Okay, so you guys have to you know, maybe for the first impression it's fine, but then after you have to work yourself. Okay, you have to prove it to the worth of the tag. Okay, fine. So is this question clear to all of you? Happy till this point? So if this is fine, then we'll go for the one last part, which is okay. I hope it's clear to all of you till this part. So let's see. Let's go for something called non-homogeneous equation. Okay. Meanwhile, I'll give you one question maybe. So if some of you can answer. Solve this. Solution of the differential equation 3y dy by dx plus 2x is equal to 0 represent a family of ellipses, circles, parabolas, hyperbolas. Single choice. 120 seconds. Start. Do this question. Come on, do it a bit quick. Yeah, ellipse. Possibly, yeah. Could be 2. Maybe. Ellipse. Okay, all of you are voting for ellipse. Ellipse. So many of the students have commented ellipse, so first of all just type ellipse. Okay, obviously voting is majority, right? True. That's what we should do, right? When majority of the people are supporting someone, we should extend our support to the same team. Is it? It's good or bad? Before we solve this question, let's have some fun for 5 minutes. Is it good or bad to support the large group of people, or to stick with our own opinion? What do you feel is better? Think, sit silent and enjoy like an IPL match. Something? Want to stick to your own opinion or keep supporting to the majority of the people? You know, unity is always a good strength, which I'll tell you, always support to the right person. Good. I'll tell you something. Yeah, of course, basically people feel that having their own opinion is the good thing. I'll tell you one small story which some of you might have come across in life, or else not. Actually, there's a hostel. Okay, in this hostel there are 100 students. Okay, there are 100 students. Clear? I'll tell you a small story because it's been some long time since I spoke some stories actually. Okay, so there is 100 students. Now when you have 100 students, and every day in this hostel dosa is being served as a breakfast. Okay, dosa is the breakfast every day. But people, there are many people who are unhappy with this dosa every day. Okay, so what, obviously when people are fighting, let's say there's a huge fight that dosa should not be served, and some people are saying dosa has to be served and all this, then the best policy is like voting. Okay, we go for voting, obviously, because obviously democracy is what, at least the word itself is nice to hear sometimes. So the hostel warden, he want to take voting actually. Okay, so he thought of taking the voting, fine, and he gave some 7-8 options so that they want to change the breakfast. Then obviously let's say the first option is dosa, second option is, let's say, maybe something like vada pav, maybe you can make it. Third, idli. They have given certain options like, okay, for maybe let's write what are the day-to-day breakfast you have. Okay, so maybe something like puri, fine. Okay, so 5, like maybe something else. So let's say you got something like poha. 6, what are the breakfast names here? I'm not getting it right. Chola bhature, yeah, we have fans of chola bhature as well, so they want chola bhature. So chola bhature, good. One more option. Can some of you give one more option? One doubt, please solve it. Yeah, you can ask doubt. You can ask, keep asking doubts. What is the other tiffin we can write? Something, someone can suggest something out of this. Pav bhaji. We have, okay, pav bhaji, fine. So let's say he want to serve one of this. So he gave 7 options like this. Aloo paratha, okay, nice. Good, okay, so enough. Let's say these are the options. Samosa breakfast में कौन देता है यार? You miss samosa. Samosa breakfast में नहीं खाते ना, snacks में खाते हैं normally. So let's say this is a fight for breakfast, okay? Then he proposed this menu and opted for voting, okay? So when it's proposed for voting, dosa got 20 votes, so 20 people are happy with dosa. But let's say 17 people are happy with this, then 16 people are happy with this, okay? Then so 7 people are happy with this. Let's say 10 people are happy with this. Then let's say again some 13, 12, 5 people only want aloo paratha, okay? Okay, aloo paratha demand is more, so let's put it maybe here some 5 here, and let's say pav bhaji is not okay for breakfast to many people, so let's say there is only 2 votings like this, okay? Now the voting gone, fine. Sum is 100 na, because being a maths teacher we should not commit mistake. 17 plus 16, 33, 33 plus 7, 40, 50, 30, 80 and 20, 100. Yeah, good, well done. So you have 100 people. Now tell me, out of this voting, which wins again? Out of this voting, if these are the voting results, then what would be the breakfast again for the people? The new breakfast. If this is the voting, then what happens? What's the new breakfast going to be? Which item has won the elections? These are the elections of, okay? Dosa, again dosa, right? So obviously because of highest votes, no, this is the again breakfast which is fixed. And first of all, why did the election take place? Because these 80 people are not happy with this dosa, that's why election got started, okay? But finally after the elections, what happened? Again the tiffin is dosa. You know what's the moral from this story? As long as the large population is ununited and fighting among themselves and have differences between them, the smallest group will take the complete power. Got it? So that's why unity is always the best. Fine. As long as unity is not there in the large population, the smallest group decides everything. Got it? So that's why stay united. Correct na? Elections happened because these 80 people were not happy with the dosa. That's why elections happened, right? But finally they lost. Got it? So being united in life is very important. With your team, with your job, wherever you go. Chalo, this is just a fun story. The dosa. I don't want to resemble any person as dosa or any person as vada pav. Just it's a tiffin and smart short story. Okay? Fine. So let's solve this equation then. So in general, solution, consider a y dy by dx plus bx is equal to 0 such that So if you integrate this, okay, so let's say if you integrate this, ultimately this can be written as ay dy plus bx dx is equal to 0. So if you integrate this, or maybe you first want to send this side and then integrate, it doesn't matter. Fine, okay. Modules enough for 70 marks in GATE civil engineering if paper is moderate. Yeah, it's enough. Okay. Its solution is we keep only 2 options. Okay. But again, people will fight, right? Your classes are very interactive. Thank you. Same with electronics elections. Okay. Back on question. Yeah, of course. We have to back on question. This is the main ultimate thing than those and vada pav. Fine. Okay. So if you simplify this guy, we have a into y square by 2 is equal to minus b into x square by 2 plus some arbitrary constant c. Okay, so maybe you can cancel this c, it is still c. Okay, if you multiply 2c, it's you have c, of course. So this tells you something like bx square plus ay square is equal to some arbitrary constant. Then you know we have x square by, I can write this as I can write this as basically root of c by b whole square plus y square by root of c by a whole square is equal to 1. So clearly a and b means basically in this case a and b are not equal. So if a and b are not equal, then this represents an ellipse. Okay, so for a not equal to b, let's say if a and b are not equal, then this coefficient and this coefficient are not equal, of course. So it is like an ellipse. It is an ellipse. And if a is equal to b, for a equal to b, obviously these two coefficients are equal, so it can be written as x square plus y square is equal to some constant square. It becomes a circle. This is a circle. Okay, so this is a circle, of course, and clearly 3 and 2 are not equal, so it's ellipse. Yeah, this time it caught the pole. Good. So Manoj, Sujay, Maulindu, Chandan. Okay, fine. My name is Vinay. Okay. So this is ellipse, of course, because this 3 and 2 are not equal in this case. Okay. So let's go back to the story of non-homogeneous equation of first order. So the general form of, or basically you can say it's not the general form, you can have any form in general. So solving equations of the type solving equations of the type dy by dx is equal to ax plus by plus c divided by dx plus ey plus f actually here. Okay, so let's say we got this ax plus by plus c divided by ex plus, okay, yeah, thank you. So dx plus ey plus f actually here. Okay, so let's say you have this equation, and obviously clearly you can sense this is a nonlinear equation because this term has 1 degree and this term also has 1 degree, but this has a 0th degree or maybe by power 0. Okay, so clearly all the terms in this are not all the terms in that are not basically homogeneous. So when all the terms are not homogeneous, of course, when all the terms are not homogeneous, then ultimately it's a non-homogeneous equation. Okay, so when you are given with these equations, and majority in GATE examination, see these kind of equations are not very frequently given, the reason solution becomes very large. Okay, but again, even if they give you, we have a technique to solve that equation. Okay, so let's do it up. So this tells you case 1 how to solve this kind of equations. Okay, so case 1, if a by d is equal to b by e actually, okay, then what we can do. Okay, so if a by d is equal to b by e means in these equations if the ratio of these two is same as the ratio of these two, then what we can do. Okay, so let's check it out. Let a by d is equal to b by e is equal to some k, or let's say some t kind of thing, or let's say some k kind of thing, maybe whatever. Okay, so let's say this is the case, so which tells you a is equal to dk and b is equal to ek. Okay, so you get this, a equal to dk and b is equal to ek actually. So if you substitute back, dy by dx is equal to, a can be replaced with this dk, so k times of dx plus ey plus c divided by this value divided by dx plus ey plus f actually here in this case. Okay, so this is the differential equation. Now this tells you, so clearly you can observe some similarity dx plus ey by substituting dx plus ey is equal to some variable, let's say t for the time being. Okay, so dx plus ey is equal to t. The above equation gets converted to variable separable form, gets converted to variable separable form actually here. Okay, so that gets converted to variable separable form actually. So let's see. And once it is in variable separable form, you know how to solve the equation. Obviously you'll show the terms to do both sides of the equation and you'll integrate it. Okay, so let's work out an example maybe to understand this. Solve dy by dx is equal to, so dy by dx is equal to, so let's say minus 2x. Okay, so this is minus 2x plus 3y plus 1, let's say for the time being, divided with, okay, so you take this m dx. So let's do one thing, let us put 2 here and minus 3 here. Okay, just for the, I just want to use one property in tomorrow's class, so that's why I'm setting up this, you know, example. Okay, what happened? Plus 2 and minus 3. Let's do it this way. 2x minus 3y plus 1 actually here. Okay, so then it becomes something like this. So fine. So here let's take the term to be something like you know what we can take x, or let me frame the question actually. So let's do something like solve x plus, just don't write for a minute, dx plus x plus fy plus, so if you take this equation to be, so let's say this is, so let's take this value to be 2 for the time being. Okay, so let's take this value to be 2y. Okay, then this also let's take it to be 2, let's take this to be 2x, and ultimately if you take this to be, let's say 3 or 1, you take, doesn't matter. Okay, so it tells you 1 is equal to, this is minus 4, let's take, okay, minus 4y, and these constants are anything, so let's take it to be 1 and maybe 2, whatever. So let's take it to be 1 and 3, let's say. Okay, so this is the equation you have. Clear? Yeah, if you have doubt you can ask me always. Okay, so let's say this is the equation, because I want to set this equation in exactly in this form, because it will be very lengthy now to solve this. You will see it almost covers 1 page, but in tomorrow's class for the same question, yeah, for the same question we can write the solution in 1 step. Okay, within 1 line. So tomorrow's class is like so many texts, so don't miss. Okay, so let's see, solve this equation. This tells you dy by dx is equal to, so dy by dx is equal to minus x minus 2y plus 1. Okay, so minus x minus 2y plus 1. So let's keep this to be 4. Okay, so plus 4 then in that case. So 2x plus 4y plus 3, this is what you get. Okay, so clearly we have, yeah, of course 2. So minus x minus 2y minus 1, so this is minus 1 again, so this is minus 1 of course, so this is minus 1, so minus 2x minus x minus 2y minus 1 divided by 2x into dy is equal to 0. Okay, so into dy is equal to 0, dy is equal to 0 of course. Clear? So let's solve this question. Yeah, okay, so I think it's in perfect form. dy into this plus this is equal to 0. Okay, good. Yeah, perfect. So let's solve this question. Okay, so we have solved this. Let's solve this. So clearly, if you see this coefficient, this is -1 and this is -2. So clearly, the ratio of x coefficients -1 by 2 is exactly equal to the ratio of y coefficients, of course. Okay, because this is also -1 by 2, of course. So clearly, this is matching with this case. So let's do one thing. This implies dy by dx is equal to minus of x plus 2y minus 1 by 2 times of x plus 2y plus 3 actually here. Okay, so that's what you get. Basically same thing like this. I have determined the working procedure. So dx plus ey, here k value is -1 whatever, and this is 2, -1 by 2, k is -1 by 2. So k value is -1 by 2. So if you take, or else we have, okay, whatever, we got this. So substitute x is equal to, or x plus 2y, substitute x plus 2y is equal to t actually. Okay, so now when you substitute x plus 2y is equal to t, let's simplify that. Therefore we have x plus 2y equal to t. So if you differentiate with respect to x, 1 plus 2 into dy by dx is equal to dt by dx. So which tells you something like your dy by dx is equal to 1 by 2 times of dt by dx minus 1, of course. Okay, so this is the value. Dy by dx is equal to 1 by 2 times of dt by dx minus 1. So let us substitute this, basically substitutions in this given equation. So therefore, if you call this to be equation 1, therefore equation 1 implies dy by dx is half times dt by dx minus 1 is equal to, the numerator is minus t minus 1 by 2 times t plus 3 actually. Okay, so 2 times t plus 3, of course. Okay, so now you can make a bit of simplification. So dt by dx is equal to 1 minus 2t minus 2 by 2t plus 3 actually here, correct? That's what you will get, right? Because if you multiply this 2 on the right hand side, you'll get minus 2t minus 2, and this minus 1 if you send to the right hand side, it becomes plus 1. Okay, so 1 minus 2t, okay, it's like 1 minus of if you take the minus sign common, it's like plus. Okay, so minus of 2t plus 2 by 2t plus 3 actually. Okay, so this is what you got. So let's see, of course, then this tells you dt by dx. Okay, so dt by dx, if you take LCM, 2t plus 3 minus 2t minus 2, so 2t and 2t gets cancelled, so 3 minus 2 is 1 by 2t plus 3. This is what you will get. Yes or no? Please type it in the chat box. So which ultimately tells you 2t plus 3 dt is equal to dx. So this is clearly a variable separable form. So this is a variable separable form actually. Variable separable form, correct? So please type it in the chat box. Is this clear to all of you? By making this x plus 2y as t and making the substitution, our equation, which is actually non-homogeneous in first order, got converted to something in terms of variable separable. Yeah, okay, fine. To all of you, please type it in the chat box. Is this clear to each and everyone? Yes or no? Please type it in the chat box. Is this simplification clear to all of you? Yeah, okay, then let's see. So obviously what you will do, you will integrate it. So if you integrate this, if you integrate that, you have integration of 2t plus 3 dt gives you integration of 2t is t square plus 3t is equal to x plus constant. So what is t? X plus 2y, okay, whole square plus 3 into x plus 2y is equal to x plus constant. So this tells you x square plus 4xy plus 4y square plus 3x minus x, 2x plus 6y is equal to constant. So this is the solution. Okay, so this is the solution, general solution actually, general solution. Okay, when I'm actually framing this question, okay, I make sure that -1, 2, -2, 4 are here, okay, but I have thought a lot to make this 1, and when I put 1 here to make this 3, okay, because I know when you have 1 here you will get 3 here, so that this function gets simplified very easily, okay. You will actually simplify this function in variable separable form, but the integrations is very simple. So to make this integration simple, I have made this thought while setting the question. You have seen when setting the question I have added so many things, plus minus signs, all I have adjusted because I want the solution to be simple like this here, okay. That's it, fine. So this is the solution. So basically we'll have non-homogeneous equations as well, so we'll solve this. The second, there's only one small portion which is left, like hardly 10 maybe like 15-20 minutes it will take, when case 2, of course, okay. So when this is not equal, okay, so in that case what to do, we'll see it in the tomorrow's class, okay. So in today's class we were basically worried about the first order equations in variable separable form, then we solved certain nice examples, this one and of course this one, which you have experienced some nice calculations. Then again this question, I have purposefully solved this question, okay, and this question as well I have solved purposefully to solve. And of course we have solved first order non-homogeneous case, one question we have solved by taking this particular example, okay. So by taking this particular example, so we have, there's one more thing which if you can solve, you can solve. It looks like higher order, but it's easy slightly to integrate. If you can think this, solve this question as homework. If you can think this, it looks like a higher order differential equation, but with the knowledge of simple integration you can solve this question, it's okay. So solve that for the homework, okay. And so today we basically looked at solving of first order equations. So we have seen techniques like variable separable form, actually. Then we have also seen homogeneous equations, of course again in first order. So we have seen homogeneous equations. Second, we have also seen the non-homogeneous equations, okay. So we have seen one case in this, see, like we have seen one case when a by b is actually equal to whatever, basically the ratio of the coefficients, okay. So whatever the notations I have taken, a by d is equal to b by e, a by d is equal to b by e is what we have taken this case. So there is one last case which we'll see, a by d not equal to b by e, that we'll teach tomorrow, and in tomorrow's class we'll talk about exact equations and the integrating factors, which is very important concept really. And also you'll observe that all the questions which we have solved very lengthily today, okay. So in tomorrow's class we can actually solve them in a single or maximum 2 lines, okay. That is the power of integrating factors and making the equations exact, which we'll see in the tomorrow's class. And tomorrow class is also on the same channel at 7 PM. So we'll continue this series, of course. And for today I'll call it a day. If you have any questions to ask, you can ask me. Fine, enjoyed the session, okay. So we'll meet tomorrow at again 7 PM and we'll discuss some stuff on ODEs again, okay, ordinary differential. Yeah, fine, okay. So thank you all, take care, bye, good night. Yeah, thanks for the heart symbols flying off, whoever it is. Can I be a faculty of GATE Wallah after GATE is, or is MTech essential? It really depends, okay. So it again depends on all your achievements, careers. There are a lot of stuff which comes up down the line, but nobody can stop you if you, okay. So probability kab chalu hoga. After this we'll teach Fourier series and PDEs, then after we'll have vector calculus and complex calculus, then we'll start probability, okay. The reason is when you are doing vector calculus and doing double integrations and all these things, it's really important to know the knowledge of double integrations and all in probability, okay, when you're doing multivariable normal distributions, all these things. So I don't want to hurry up there, so just stay focused, okay. So thank you all, then take care, bye.